Hi, I'm Felista Maina, and I'll be taking us through linear congruences. For starters, a linear congruence can be assumed as a linear equation where we're solving for an unknown. A linear congruence is denoted in the form of this shown, where x is the unknown that we're looking for, and the solution is given in congruency form, in this format. So when solving for linear congruences, we have two separate types of linear congruences that we're going to solve. First is where a and n are co-prime, and the second is where this a and n are not co-prime. So when solving for linear congruences where a and n are co-prime, the first step is to find the multiplicative inverse of the modulo n so that we can use it to solve for the linear congruence. So how are we using the multiplicative inverse? We're going to use it by multiplying both sides of the linear congruency by v, which is the multiplicative inverse, not index, sorry. So after solving it, we make x the subject of our, let's call it a formula or equation, and we have this as shown here. In an example, I have 5x congruent to 6 modulo 9. So the first step, as I've said, is to find the inverse of 5 modulo 9. And of course, the inverse of 5 modulo 9 is true since it has to satisfy the congruency statement 5v congruent to 1 is equal to modulo 9. So then we come and do our calculations. We first multiply both sides of the equation by v, and we get 2 into 5x congruent to 6 modulo 9. And then moving on, we simplify and solve the congruency to get our value of x as 3. So then we denote our congruency equation as we have indicated here in form of x, where x is the subject. So x congruent 3 modulo 9 becomes our answer. Next is